In this video, we are going to do some examples involving the normal distribution. We will be finding some probabilities. Example, Dutch people are among the world's tallest. In the Netherlands, female adult height is normally distributed with a mean of 67 inches, that's 5'7", and a standard deviation of 2.5 inches. So the first question we want to answer is, what is the probability that a randomly selected woman will be shorter than 64 inches? In other words, what proportion of Dutch adult females have heights less than 64 inches? So what percentage of Dutch adult females have heights that are less than 64 inches? So the first thing to note is this is actually what we call a non-standard normal distribution. So I will be computing z-scores, okay? And we are told here that the mean is 67 inches, so I'm going to write mu is 67 inches, and the standard deviation is 2.5 inches. So in this case, we are looking for the probability that the height is less than or equal to 64 inches. And so what I need to find is the probability that the z-score is less than or equal. So what is the z-score that corresponds to 64 inches? Z is given by, remember, x minus mu over sigma. So that would be 64 minus 67 over 2.5. Be careful about the ordering here. I often see students get that backwards. And that ends up being negative 1.2. That's my z-score. So in order to find this probability over here, I need to figure out the probability that a z-score is less than negative 1.2. Okay, and in order to figure out that probability, I am going to be using, I'm going to be doing this problem by hand, so I'm going to use the normal table because our z-score is negative 1.2. And I find the negative 1.2 here. The digit in the hundreds places is 0. So that tells me, so remember I had negative 1.2 and then there was no, there was just a 0 there. So that tells me that the area to the left of this z-score is 0.1151. And that would be our final answer. And so let me just draw a picture of what that looks like. So if this is my normal distribution, okay, for these heights, we know that the mean, which sits in the middle, is 67 inches. And so let's suppose x represents height in inches. Then the original question was asking us, what is the probability a randomly selected woman has a height less than 64 inches? Or in other words, what percentage of the women have heights under 64 inches? So this question is really asking us to find this area. And we did, and we found that this area was 0.1151. This also means that about 11.5% of Dutch women are shorter than 5'4", which is the average height in the United States. So here is a second question. We would like to know what percentage of Dutch women are taller than 72 inches. So that's 6 feet tall. So in other words, if I were to randomly select one woman, what is the probability her height would be greater than 72 inches? And let me just draw a little picture of what we're looking for here. So if this is my normal distribution for these heights, okay, in the center, I have the mean, which is 67 inches. And somewhere over here on the right, I will have my 72 inches. So this question is really asking us to find this area. Okay. So let's get started. So we are looking for the probability that a height is greater than 72 inches, greater than or equal to 72 inches. Again, this is a non-standard normal distribution, so I will be converting to the z-score so that I can use the table. So what is that z-score? So we've got okay, so this gives me a z-score of 2, and we got lucky again that the z-score, we didn't have to do any rounding, but generally you want to round your z-scores to 2 decimal places, okay? And we didn't have to in this case. I mean, this is just basically 2.00. So one thing that we have to be careful about with the normal table is that the normal table gives me areas to the left. It does not give areas to the right like this one. So if I were to look up this z-score, which is z equal to 0.00, the normal table is actually going to give me this area. So one thing that I can do to figure out this area is use symmetry and use the fact that this blue area is the same as the area to the left of z equal negative 2.00. Okay, so in other words, this area is the same as the area given by this probability. Okay, so we're going to be looking up negative 2 in our normal table instead. So here we are back in the normal table. I've got my negative z-scores, and over here you can see negative 2, and you can see the 0. Okay, that's for a z-score of negative 2. And then in the body of the table, we have the areas or the probabilities and percentages. So you can see I have 0.0228. So here's my final answer. And so this is about 2.28%. So if you think about that, this is saying about 2.28% of Dutch women are taller than 6 feet. I want to point out just one other way that you could have solved this problem. So in order to calculate a probability of this form, so the probability z is greater than or equal to 2, which is this area, we can just calculate 1 minus the probability that z is less than or equal to 2.00. And we can use this subtracting from 1 because this we can look up using our normal table quite easily. So if I go back to the normal table, so I'm going to go to the positive half of the normal table, and you'll see that 2.0 corresponds to 0.9772. That's the area. And this also gives me 0.0228. So I get the same final answer. So here is my final question for this video. What is the probability a randomly selected Dutch woman will have a height between 66 inches and 71 inches? So that's 5'6" and 5'11". So how do we answer a question like this? So again, let me just draw a little picture of what this might look like. So here I have my mean. 66 inches is somewhere to the left, and 71 inches is somewhere to the right. So basically we are looking for this area right here. So that is going to give us the proportion or the percentage of Dutch women having heights between 66 inches and 71 inches. Okay, writing that in probability notation, we have what is the probability that a randomly selected woman is going to have a height between 66 and 71 inches. And so let's calculate our z-scores down here. Z is equal to, remember, the height should go first and then the mean. Okay, and performing this calculation, I get negative 0.4. Now I'm going to do the calculation for 71 inches. We expect that to be positive. Again, I'm lucky I don't have to round, but if you did have to round, always round your z-scores to 2 decimal places. Now, my next step, so remember I have now converted to z-scores. So I am going to use the normal table, and I'm looking for the area between these two z-scores. And so the way that I'm going to calculate this between area is I am going to calculate first the area to the left of 1.6, the 1.6 standard deviation. So that represents this area. Okay, so that is going to be my first step. And then I'm going to calculate the area to the left of negative 0.4. So that is this area. And I'm going to subtract this area from the first area. And then that will give me this middle area. So just to recap, I first calculate the area to the left of 71 inches, or 1.6, a z-score of 1.6. And then I'm going to subtract the area that's to the left of negative 0.4, a z-score of negative 0.4. Okay, and then that gives me this area. Okay, and so 1.6, so that's 9452 is the area to the left. And then we have in the negative z-scores, we have negative 0.4. And area to the left is 0.3446. So from the table, I have 9452 minus 0.3446. So about 60%, okay, of the women have heights between 66 inches and 71 inches.